Welcome to number 8. Today we will be solving problems on powers of 10. Powers of 10 is used for scientific notation, and here I will show you how to use it. First of all, let me tell you about the rules. This is going to refresh your memory on how to use the powers of 10. This 10 has a power of 3, so that means this number can also be written as a 1000. When it's a multiplication, we will be shifting places to the right. This shift on places is on the decimal point. So since it is 10 to the 3, it is 1000, so there's 3 zeros. So we'll be shifting this point 1, 2, 3 places to the right. So this number can be written as 426. When we are doing a division instead, and this is a 10 to the power of 2, so this can be written as 100. In the division, we will doing the opposite, so moving to the left. So in this case, this decimal point will be moving 1 and 2 places here. And the empty place we fill with a 0. So our number will become a 0.05201. When we are doing this kind of problem, we want to convert a number that is not on power of 10 notation to a power of 10 notation. We want to work backwards. So in this case, this number I want to translate it so that it keeps an equality. So I want to move 3 places to the right. That is actually a power of 10 to the 3. So in order to compensate the equality, I want to work backwards and write the number times the opposite. So in this case, a power of 10 to the negative 3. This way, these two powers mean the same when we are doing the equality. Alright, so let's see it in another example. In this case, for example, I want to move this place one more. So that means I'm displacing to the left, so this is a power of 10 to the negative 1. So I can keep the equality by doing the opposite to that, so 2.18 times 10 to the positive 1. In this third problem, we want to move 4 places to the right. So that means this is a change of 10 to the power of 4. So to keep the equality, I do the opposite, so I can write this as 68 times 10 to the negative 4, such that these two numbers mean the same. Alright, let's do this. For example, let's move this 2 places to the left. So that means there is a 10 to the negative 2 shift. To keep the equality, I gotta do the opposite, so I'm gonna do 3.2865 times 10 to the power of 2. Again, you can check in your home that these two numbers are equal. In this case, let's move this point 3 places to the right, so that means this is a 10 to the positive 3 shift. So to keep the equality, I will do 219 times 10 to the negative 3. And our final problem, let's move this 3 places to the left. So that means this is a 10 to the negative 3 shift. And to keep the equality, what I want to do is the opposite. So 0.444 times 10 to the 3. Remember to keep practicing these problems and come back to numerator for the power soft.